Okay, in this problem, we're going to be solving the equation 2 cosecant of x minus 2 is equal to 1 over sine of x. And cosecant and sine are reciprocal identities on the trig hexagon. So we can rewrite this equation instead of 1 over sine of x as the cosecant of x. Okay, then if we subtract the cosecant of x from both sides, 2 cosecant of x minus 1 cosecant of x leaves 1 cosecant of x. Then we're going to add 2 to both sides, and the cosecant of x is equal to 2. Now, cosecant, we said, is the reciprocal of sine, so I can apply that reciprocal identity again to get sine of x equals 1/2. And then x is equal to the arcsine of 1/2 when we take the inverse of both sides. So arcsine of 1/2 is asking the question, where on the unit circle do we have angles that have a y-coordinate of 1/2? And in the first quadrant, our angles are pi over 2, pi over 3, pi over 4, pi over 6, and 0. And it's pi over 6 that has a y-coordinate of 1/2. Recall that coordinate at pi over 6 is root 3 over 2, comma 1/2. So our principal value is our quadrant 1 angle of pi over 6. Then our acronym, all students take calculus, that reminds us that sine is also positive in quadrant 2. So our quadrant 2 solution is going to be 5 pi over 6. And we're going to check both of those answers in the calculator. So we're going to first look at the mode and make sure that we're in radian mode, which we are. Then we can store pi over 6 as the x value. Then we're going to type in our original equation, 2 cosecant of x minus 2, but there is no button on the calculator for cosecant, so we're going to need to use the reciprocal, which is 1 over sine. So 2 divided by the sine of x instead of 2 cosecant of x, then minus 2. Then we get the equals from the test menu, and that's equal to 1 over sine of x. We press enter, we get back a 1, which tells us that pi over 6 checks. Now we're going to check 5 pi over 6 by storing that as our new value for x. We'll arrow up to the equation and press enter, and there we go, we've got a 1 again, so 5 pi over 6 also checks.